All right, let's start off by building a foundation. We're going to talk about what sugar is, some of the quality perspectives that you have to keep in mind when having it in a formulation. And then we'll also talk about how sugar relates to moisture in food formulations. So generally, table sugar is sucrose. This is a disaccharide of glucose and fructose. It usually comes from either sugar cane or from sugar beets. And usually it's produced in, the top producers include India and Brazil and Thailand, just to name a few places. So Mary's going to tell us a little bit about sucrose and what to consider when using this in a formulation.
Number one is the sweetness. It is the standard that everything is compared against. It also gives enhanced flavor. So besides just the sweet, as it chemically breaks down, it's going to bring out other flavors in your product. It also is influencing leavening in three different ways, actually. So we have aeration caused by sugar trapping air in the fat molecule. We have yeast. The sugar is used up by the yeast. And then it also stabilizes egg whites while it binds to proteins. And lastly, it will deepen the color. So it uses the Maillard reaction to react with amino acids, and it'll get that nice, beautiful brown in your baked goods.
And the way that moisture starts to fit in here is that sucrose is a polar molecule. So there is going to be a hydrogen bonding effect with water. You're going to have positive areas of water molecules interacting with the negative areas of sucrose. And because of these interactions, sucrose is a really good humectant. It's something that will bind or lock up water so that it's not available for other reactions or microbial growth or other things you might be concerned about in your food. How else does sucrose interact with water?
Yeah, it is actually a major component of formulations, is that reaction together. How does water and sucrose bind together? So number one, it creates tenderness because it'll absorb the water, reduces gluten formation. So you'll get, reduces the staling of bread. And it also delays the coagulation of proteins as well. It adds a crunch. So as, you bake something, the moisture is going to evaporate on the outside and the sugar is going to recrystallize. As we already mentioned, it's a really great humectant, which means it just straight up binds with water and increases the moisture content. So if you want something to be more tender or, have more moisture in it, then, adding sugar is really going to help with that. It also is really good at extending shelf life because it does lower that water activity. It inhibits the microbial growth, but it also starts limiting chemical reactions and just improves overall stability. Lastly, it lowers freezing point. So if you're looking at ice cream, what happens is it will bind with the water and then it'll keep it from that water from crystallizing in those frozen dairy products. So these are all really important and huge effect in all products that have sugar in them.
That's a great point, Mary, and that's why in this next section we're going to talk about the science behind substituting some of the sugar with alternative sweeteners. There's a lot to keep in mind, like you just went over. All of these different characteristics are impacted by sugar. It's not just sweetness that we're looking at. So we're going to start to talk about some of the characteristics of final products to keep in mind, and then also try to define what it means to have a clean label and how these sugar substitutes fit into that. So as far as replacing sugar is really complex and much more sophisticated than it might appear at first. And as you change it, keep in mind that this has a really big impact on the water activity. This goes back to when we mentioned humectancy. So anytime you change water activity, this can have an impact on the physical characteristics of that product. You have to keep in mind the texture that you're after. If you're going for a certain crunch or crispness, whatever that texture is, as soon as you remove sugar, the texture may change as well. You have to keep in mind chemical effects. So as you change the water activity, certain chemical reactions may increase or decrease in speed. Also, if you replace with a sugar that's not going to brown the same, then there's going to be an impact on browning reactions. And then there also may be a biological impact. So as that water activity changes, this may increase or decrease the susceptibility of that product to biological growth of certain microorganisms.